Today in class we're doing a lab. The lab is our heat stations lab. There are 6 rotations. They should go by fairly quickly and cover simple concepts. You will have your own sheet of questions. There will be 3 or 4 for each station as you rotate through. Whenever you get to a station, the first thing you should do is look at the placard. It'll give you some basic instructions as well as give you the ideas of what you should be thinking about. Now our first station here is heat transfer in liquids. So we're looking at convection. We have set up a beaker with, we put some oil and some glitter and food coloring. Really we just put things in there so that you can see them. And if we look closely, this thing's sitting on a hot plate. There's been no stirring here, no other source of motion other than the heat. So our kinetic theory explains to us that the motion of these particles is only due to thermal expansion, changes in density, convection. If you look closely, you can see some parts are rising while other parts are falling, depending on their densities. After you've answered the questions on this lab, made your observations, before you rotate to the next station, the last thing you'll do is a summary. There's sentence writing. You'll need to select one of the vocabulary words and write a sentence next to your group number. If you're the first group here, you'll have free selection of any of the vocabulary words. If you are a second or later group, you will have to use what vocabulary words are left. You cannot repeat any. If you see any errors in the other groups, please make any corrections and initial your group's number there. Station 2 deals with entropy. Entropy is a complicated system in physics, but it can be modeled very simply. A lot of entropy has to do purely with statistics, with chances. So our model here of how particles are moving and organizing themselves, we're using pennies to represent our particles. We have a stack of 10 pennies. After we read our instructions, we learn what we're going to do. We stack them up all the same way. We will put them into the bottom of this cup. And make sure our stack is neat and clean, but they're all stacked the same way. Our pennies have a high degree of order whenever the pennies are turned upside down. We'll look and count how many are of each side, and we see that we've had a change in order. Now we're talking about the chances of how many would be heads and tails. While there is a possibility they could all be one or the other, odds are they're going to be somewhere in the middle, more evenly split. After you've made your observations about entropy, make sure you answer the questions using the vocabulary words, and then write your sentences. Station 3 is our amazing ice melting blocks. Make sure you read your instructions here. We look at our materials. We have 2 black discs. We have a little bit of ice here. Our instructions are to take 2 ice cubes, place 1 on each disc. Now at the beginning of this experiment, each of these discs were in thermal equilibrium. Thermal equilibrium means that the 2 were the same temperature because they've been sitting in this room long enough to exchange any heat. Come to that equilibrium. However, while both blocks seem apparently to be the same, you notice a dramatic difference in the rate of energy transfer between the black disc and the ice cube. While one of our ice cubes is nearly gone, the other ice cube has yet to even leave a puddle there. Now both ice cubes are identical. They come from the same source, the same material, or the same temperature. There is, however, a difference in material between the 2 discs, which can cause differences in the rate of energy transfer. Make sure you answer the questions for each station as you go along on your student sheet, and then each station has attached to it your sentence writing. Here I have an infrared thermometer. It has a trigger here, a readout on the back, shines a laser dot. Whatever the dot is on, it'll tell me the temperature. So the temperature of this table is about 70 degrees Fahrenheit. If I point it at the bag of ice, see we're about 33 degrees Fahrenheit. You can see as I point at the different ice cubes, they're all about the same temperature. Again, if I point it at my discs here, so I have two more discs, you can see this one's at 73, this one's at 73. They are both starting at about the same temperature because they're at thermal equilibrium. Station 4, the same temperature. In Station 4, we're using our sensory information to gather about different blocks of different materials. Remember, we have questions to go along with it to guide our thinking, and at the end we're going to write a sentence about understanding using our vocabulary words. Now, before I start touching them, you will not have this available at the station, but I just want to show you that no matter which one I'm looking at, the temperature is always about 73. Scanning between all of them, 73 to 74. They are all actually the same temperature. However, when I touch them, different ones, I have some pine wood, oak wood, some acrylic plastic, some PVC plastic, aluminum metal, copper metal, and steel metal. Now, because of their different properties and their different chemical composition, they do feel different to me even though they have a different temperature. The questions are to guide your thinking from here and make sure to use your vocabulary word in your explanation. Two different t-shirts, a black t-shirt and a white t-shirt, and they're sitting underneath this sun. So as the sun bears down on them, the radiation is absorbed differently by the two different colors. So I can take my temperature gun, point it at the white one, and I get 113 degrees. Now if I go to the black one here, I point my temperature gun at it, I'm getting 135 degrees Fahrenheit. These are very dramatic differences. Now you see I also have two temperature probes put in there. I also have a digital readout. So channel 1 temperature, 43.9 degrees Celsius, that's my white one. Channel 2 temperature, 48.4. That would be the black t-shirt. Station 6, where is it all going? This is talking again about the kinetic theory of temperature, the motion of molecules. So we have a temperature probe set up. It's reading 23.5 degrees Celsius. It's currently stuck inside of this cup. These two cups are taped together. Inside, all we have is sand. So I'm going to take this sand, by adding kinetic energy to the particles, I can change their temperature. It's important to get a significant reading to shake vigorously, and to make sure as soon as we stop shaking that we want to take the temperature immediately so it does not have time to cool off with its surroundings. The longer that we shake and the faster, the larger a temperature change that we'll see. So we started at 23.5 degrees Celsius. As we're reaching our equilibrium here with the thermometer, we're up to about 24.6 degrees Celsius. Remember to answer the questions on your student page that corresponds with the station, and write your sentence using whatever vocabulary words are left.